So up to this point, we've gotten data into R by manually typing it in and assigning it to a vector. And what we're going to practice now is different ways to bring data in to R from external sources. So the first thing that we're going to do is go ahead and download a XLS file from or Excel file from the publisher's website and convert it to a .csv file, which is what R likes to use, and then bring it into R. So if you get on the internet and you go over to pearsonhighered.com /studentmund, then you go down to datasets and find the datasets for the book. In this case, we're looking for chapter 17, which is what serves as our introductory chapter in the short book, and then Excel and stats, and then you want to go ahead and open it with whatever spreadsheet program you have on your computer. LibreOffice in this case, or Microsoft Excel will work fine. And you can see the data here, and you're going to go ahead and save it as a file that's a CSV. So if you go down here and find .csv, and I think I'm going to put this in the R folder that I found here. So put it in some folder and remember where you put it. And we're going to use text CSV format. That's fine. And then if we go back into R, then we can go find it. So right now, let's check what our current working directory is. So we're going to say get wd, and I need to change it to the folder that I saved the file in. So I'm going to go set wd, and I'm going to change that again, just like we did in the beginning. Oops, I forgot the / in front of users, so careful about that. And now we're going to type in dir with a open paren, and it'll close it. And this is going to tell us everything that is in our current working directory. And as you can see, our file stats17.csv is right there. So that's great. So now what we need to do is read the file into R. So come up with a name that you want to name the data. So in this case, I'm going to follow along with the text did and say data 17, and you're going to do that less than sign again with the dash, and you're going to say read.csv, and then you're going to put the title of the document that you're trying to read in quotes, and write the title exactly as it appears, paying attention to caps and the like. And you're going to put a comma after the quotation marks and say header equal capital T for true, and this tells it that the first line of information in the CSV file are the headers, so it won't treat them like data and just form new headers on top of it. So now if you type in data 17, R will show you the data that you just brought in. So as you can see, we've got there, the columns are observation, number, price, and square foot. So anytime you have R display data like this, it's going to show you the whole data set, or data frame as they're called in R. Data frames in R are what's formed when you read a CSV into R and call it something. It's basically R's way of storing tables. So this data frame is relatively short, so I can see the whole thing here, but if you had a really long one, R would literally spit out the entire data set at you. So you could say head paren and then data 17, and then R will show you like the first 6 rows of data and the headers. And if you said tail of data 17, R will show you again the column headings and the last 6 rows there. So now one other thing that I'd like to bring up is that there are a couple different ways to get R to show you specific data items that are, within the frame. So let's say that you wanted to see what the square foot was for the 6th house. So you would say data 17 and a $sign, and then type in the name of the column within the data frame, so SQFT, and then square bracket, and then you would say 6, and then so then it'll go and find data frame named data 17. It'll go to column SQFT, and it'll return the 6th row from that column, right? So that's one way to do it. There is another way to do it. If you typed in data 17 and then you had a square bracket, and then in quotes you put the row, so you would say 6, and then a comma, and then in quotes you would put the name of the column, so SQFT, and then that'll return the same number there. So there are a couple different ways to get this data, and I just wanted to show you that so you could start to get a feel for manipulating these data frames. It would probably be a good thing to practice. So now we're going to pull up some summary statistics for this data. So if you did summary open paren data 17, it'll list summary statistics for each column there. And if you want to do a scatter plot of the data, you would do plot paren data 17, and let's put the column of square foot on the x-axis, and then comma, and then we're going to say data 17 with a $sign and price on the y-axis, and then that'll pull up the scatter plot as you told it to. There's another way to access the names or labels of columns like square foot and price. You can do what they call attach a data frame. So if you said attach data 17, then R knows that whenever you ask for some data from some specific column name like price, it knows that you're asking for it from that data 17 data frame. So now you can just say plot square foot SQFT and price, and it knew to look at data 17 data frame because you had attached it. It's generally good form to deattach it when you're done, so we'll do that in a second. I want to show you that you can also find the correlation between these two things fairly easily in R. So if you did COR and SQFT, comma, and price, you'll notice that this time I put a space after the comma, and before I didn't. In these basic commands, R can typically handle that, so it's not like you're going to break, the software. So anyway, it'll spit out the correlation there, so that's great. And then if you're done with the data frame as we are right now, then you just type detach data 17, which is kind of like the proper thing to do when you're done. Otherwise, future commands you do might be going back and looking at this data when you're really not too concerned about that old data. So let's check again and see what R has in its memory or in its workspace image by typing ls open paren, and you can see it's got all this stuff here, including, if you look carefully, the stuff that we added like capital X and Z and Z draw. So let's clear out the workspace image by typing rm paren list equal to ls open paren, and then R is going to automatically close those for you, so that's great. And then you hit enter, and it just erased all of your objects from your workspace image. You can check that by typing in ls, so it just blew those all away. And so that's just a way that you can clean that out. As you do projects and assignments, you'll notice that it gets pretty full. So again, keep in mind the workspace image, which we just cleared out, is always saved in the working directory that you leave the program in. So the next thing that I like to talk about is that in this class, some data will be easily available directly from the internet. So let's try and bring in a CSV file directly from internet URL. So in this case, again, we have to name the data frame or tell R what we're going to call this file that we're about to bring in. So we're going to call it data, and we're going to do the less than sign in the dash, and we're once again going to use that read.csv command and open paren, and then in quotes we're going to type in this internet address, which again is listed on the document in the introductory course module available on Canvas, but I'll repeat it here and hopefully not mess it up too much. HTTP : so we'll do content.csbs.utah.edu / squiggly fowls / econ 4650 / data / stats 17. Try and get the caps right. I didn't once and it didn't like it, so keep that in mind. And again, we're going to tell this that we're going to tell R that the first line is again a header. This is essentially the same file we just brought in. We're just practicing getting it. So and header equal to true, and hit enter. And it didn't give me an error, which is always a great sign in R. So let's type in data, and excellent. There it is.